Hello everyone, welcome back to my channel. Today we are going to solve one of the most important question on Leetcode, and that is a graph question, that is flood fill. So basically we are given a 2D matrix called image, and we do also have a starting row, starting column and color, right? And our task is to very simple. We need to replace every connected pixel which having the same original color with the new color, right, which is given in this question. We replace with this color, and the original color is nothing but the starting pixel, right? The starting pixel is image of ij, and I is starting row and j is starting. So let's understand this visually. So here you can see we have a starting row, starting column, and we have color. Right? And it is also given in the question that we need to start from starting pixel, which is nothing but image of starting row and starting column. So, our starting position is this pink cell according to this starting row, which is 1. So, means image of 1 comma 1, which is going to be this pink cell, right? And its value is 1. So, and our new color is 2, right? We need to replace it with 2, which is given in this question. I'm just taking this example, right? It is given. So we need to replace it with this 2. This is going to be our new color, right? Now here the most important point is we don't have to replace everyone, right? Everyone with this new color, right? Which is this image. We don't have to replace everyone. And why we are taking 1? Because it is a starting pixel and starting pixel value is 1. So we need to replace the 1th value by this color too, right? But we also need to notice that we don't have to replace every one color, right? We only have to replace the one that are connected to the starting cell, right? Which are connected to the starting cell or starting pixel, which is this one, right? And notice these blue cells, right? Notice these blue cells. These are connected through upward, downward, or leftward or rightward directions, right? So that is why just these are going to be changed into new color, right? And so we just have to change them into 2, right? But look at this bottom right one, which is not changed. We don't have to change their color, right? So many of you think like it should have to become 2, right? But actually it is not. And why? Because there is no path which are connected to this starting cell, right? Because these zeros are just blocking the path. You just have to change those cells only which are just directly connected. But because of these different pixels, we are unable to reach this cell. Right? So that is why this zero block, these zeros blocks are just blocking the path. That is why we don't have to change this one, right? So the flood fill only spread through the connected cell, right? So let's let's take a real life analogy. Uh, think of pouring a water on a floor. So you can see this. We have just pour a water on the floor, and this water is just spreading through this open spaces only, right? So if there is a block, right, here is a block, so it's just blocking the path, and water cannot cross these walls, right? So the flood will work exactly the same way. What I'm just telling is just these zeros are just acting like a wall. So that is why, because of these different pixels, we are unable to reach this bottom right element, right? So that is why this cell is going to be unaffected, and that's okay because we just have to return as it is the image. If we are unable to reach those cells, that's fine. We just have to return it, right? Now, the next question is, how does the algorithm move? It can only move in four directions, right? We just have to move in four direction: upward, downward, left side, or right side, because it is given in the question. Here it is given the question that the pixel that shares side with the original pixel either horizontally or vertically. We don't have to move diagonally. Okay, so which is vertically, upward, downward, or horizontally, left side or right side? Here only we need to traverse, right? So it can move only in four directions, that is upward, left side, downward, or right side, right? And no diagonal move is not given in the question. So mathematically, up means what? Up means we are just decreasing the row. So if an element present at a 0 comma 0 and we are just moving in upward direction, so we are just decreasing the row, which is going to be minus 1 comma 0, right? And if you are just moving left side means what? We are just decreasing the column by 1. For downward direction, we are just increasing the column by 1, which is going to be 1 comma 0. And for right direction, we are just increasing the column by 1, right? So this is how we are just going to get the indexes of upward, leftward, and downward, right, and rightward direction. So instead of writing four separate if statements, we are just going to store these direction inside a list and then we're going to iterate over it, right? So this makes our code a bit of shorter and clearer. So it's become easy to understand. Now, here, here we come with this our intuition. So because this question is of easy level and we do have a two approach to solve this question is using BFS or BFS. So I'm just using BFS to solve this question. If you have a project to solve this question using BFS, because it's an easy question and we're gonna go with these two directions, like either you can use a DFS or BFS. If you know the DFS, you can solve this question by DFS. But in this question, I'm just using BFS, that is breadth first search. And we know in breadth first search, we are just going level by level, right? And in BFS, we do have always a queue, and but this queue is nothing but a D queue. Just we are just have to import this queue from collections, right? And this queue is actually a D queue that is double-ended, right? And I don't think that I have to recall all the properties of queue that follow FIFO, that is first in, first out, right? Because we are solving a graph question, and this is one of the basic data structures, so I don't have to explain. Okay. Uh, now we know that we need to start from the starting pixel, which is already given in the question. So now let's take a variable. There I'm going to store a starting pixel. So let's take a starting pixel, right? Which is going to be image of starting row, which is given in the question, and starting column. So we need to start our question from this pixel, right? And in this question, our starting pixel is 1 and starting column is 1, right? It is given in the question, right? So this cell is going to be our starting pixel. Now, next, what you need to do, you just have to take their coordinate and put it inside our queue, right? So we are just taking their coordinate, and a coordinate is nothing but a starting row and starting column. And starting row is what? 1, and starting column is 1, right? So we just have to put it inside our queue. Now the next step is to just pop out this element, right? Until and unless the len of q is not going to be empty or zero, we just have to pop the element from our queue. So I'm just popping this element. You just have to pop this out of this queue, take it out from this queue. And now, what the next you have to do is to just change their color to color, which is given in the question. Color is what? 2, right? We need to change their color to the new color, which is going to be 2, right? And now the next step is to just move upward, then left side, then downward, and right side. We just have to move in these 4 directions, right? And then if one of the value is going to be matching with our starting pixel, then we need to add their coordinate inside our queue. For example, this starting pixel is already changed to our new pixel. Then what we need to do is to just move upward direction. In upward direction, we can see this this value, this element is equal to our starting pixel. Our starting pixel is actually 1 now, so this element is actually equals to the starting pixel. Means what we need to do is to just add their coordinate inside our queue, right? So what I'm going to do is I'm just going to add their coordinate, which is going to be 0, comma 1 inside our queue, right? Now we just have moved upward direction. Now let's check in leftward direction. We do have 1. Again, this element is equals to the starting pixel. So we just have to add their index inside our queue. So if those elements are just matching to our starting pixel, then nothing we need to do is to just add their coordinate our queue, right? So which is going to be 1, comma 0. So add it 1, comma 0. Right. Now let's move towards downward direction. So if you're gonna move in downward direction, you're gonna see element which is not equals to our starting pixel, right? This 0 is different pixel, right? Which is not equals to the starting pixel, or we can say the original pixel. Then we do not have to do anything, right? We just have to do continue. Continue means what? We just have to skip that iteration, right? We don't have to do anything. We don't have to add their index inside our queue, right? Because this is a different pixel, not equals to our starting pixel. Now let's move rightward direction. In rightward, you're gonna see a pixel which is again not equals to our starting, and that is the problem, right? So these pixels are just working like a wall, and that is why we are just unfortunately not able to reach this element. So that is why this element is going to be unaffected. I hope it is clear. So that is why we're not going to add their indices inside our queue. We don't have to add this because this is a different. Okay, now let's rub this, and now again we're going to repeat this process. We're going to again pop one of the element. Popping is what? This I'm just telling you. This Q is DQ, and in DQ we do have a property called uh, pop left, right? So we are just applying those properties like pop left, right? So I'm just popping left, which is going to be this 0, comma 1. Okay, so at 0, comma 1, I think this element is going to 0, comma 1, right? So 0, comma 1, what you need to do is to just replace it with the new color. Again, it's going to be 2. And now again, we need to move in 4 direction. That is upward, downward, left side, and right side, right? So in upward direction, we didn't have any element, right? And this is going to be one of the edge case that I'm going to discuss later in this video. But here you can see we do not have any element. We're not going to do anything. Now in leftward direction, we have an element which is equals to the starting pixel. Then we don't have to wait anymore. We just have to add their pixel, I mean their index inside our queue, which is going to be 0, comma 0. Right now, in downward direction, if we're going to see in downward direction, the element is already changed it in new color, right? And because this is the new color, it's become a 2, right? And 2 is not equals to starting pixel. Then again, we're going to skip, right? We just have to ignore this, or we just have to write a continue, which is going to be skip this direction. Okay, now let's move to the right direction. In right direction, again we get a pixel which is equals to the starting pixel. Then we're going to add their index inside our queue, which is going to be 0, comma 2. So I just have to add this 0, comma inside our queue, right? So as we can see, we have already traversed in all the 4 directions. So we need to rub this, and now let's pop the another element from our queue. So let's pop out the pop left. Just apply the operation called a pop left. Okay, 1, comma 0. So we have this 1th row or 0, 0, which is this element 1, comma 0, right? And so what we need to do is to just change their color to color, which is going to be 2. And now let's again traverse in all the 4 directions. And upward direction, we do have 1, which is equals to the starting pixels. So we're going to add their index inside our queue, which is going to be 0, comma 0, right? So you might have a question that we have already add their index inside our queue, and we are just adding again this 0, comma 0. So nothing is wrong, right? Um, we do have to do the exactly same. If we get a duplicate inside our queue, so nothing is wrong, right? Okay, now let's move on this. We can say this left direction. So in left direction, you can see we didn't have any element. So this is also one of the edge case, right? I'm going to discuss later on. So we don't have any elements, so we're just going to skip it. Now, in downward direction, we have an element which is equals to the starting pixel. So we're going to add their index inside our queue, which is going to be what? 2, comma 0. Right? I'm going to add it, comma 0. All right. And at rightward direction, the element is already changed to different colors. We just have to skip. Now let's again pop the element from our queue. So let's pop this. Okay, first of all, just grab this, and now let's pop this. Okay, this element is coming out from this queue, and 0, comma 0. So let's change their color to the new color, which is going to be. And again, we're gonna traverse in 4 direction: upward, downward, leftward, and rightward. And you're gonna see every color has already been changed, right? And we are unable to reach up in left side, so that's okay. Okay, now let's rub this, and now let's pop the another edit. Let's rub, and now let's pop out the next element from our queue. That is going to be 0, comma 2. 0, comma 2 is this element. So now let's change their color to color, which is going to 2. Okay, now let's again move in all the 4 directions. So upward, we didn't have element. At the right side, the element has already been changed. And at downward direction, we do have a different element. And right side, we didn't have element. Okay, let's rub this, and now let's pop again. We're gonna pop the next element. Pop is what? In DQ, we're just performing pop left operation. I'm just telling again. Now 0, comma 0. 0, comma 0 is already been changed to the next color, or the new color, right? So we don't have to do anything, just skip this. We just have to rub this. And now let's again swap the next element from our queue, which is going to be 2 comma 0. So let's 2 comma 0 is this one. So let's change their color to the new color, which is going to be 2. And as we can see in all the four directions, we do have a different element, right? So we don't have to do anything. So let's rub this again. And here you can see our queue is equals to empty, and that's the point that here we have to stop the iteration. So if the len of q is equals to empty or equals to 0, right, or equals to none, so in these conditions we do have to stop. And here you can see the walls, which is 0 comma 0, or we can see the different color through which these colors are not just making us to reach this bottom right element, right? So unfortunately, this element is unaffected, and that's okay. And this is what the entire intuition, right? So now here we just understood the intuition. Writing the code become extremely simple, right? So let's switch to the lead code. Okay, just yeah. So initially, I just import DQ from the collection, right? And also, we are not doing all the operation on our original image or original metrics, right? We are just making a copy called a deep copy. So I'm just importing that deep copy from copy. Okay. So let's start this problem. So basically, as we know, we need to start from starting pixel, which is already given in the question. So let's make a variable called a starting pixel. I'm gonna make them a starting pixel. So our starting pixel is nothing but image of starting row, which is already given, and starting column. All right. Now, as we know, we are just making a copy of image. So I'm going to store it in copy. So copy is actually going to become the copy matrix or copy image, which is going to be deep, deep copy, deep copy of image, right? So here we have a deep copy of image. And also one more edge case is there. Let's come to this solution. And here you can see one of the most optimization, I just want to explain it. If let's suppose if this is the starting pixel, right? If a starting pixel is already equal to the color, right? If it is already given in the question, or if it is already there in image that our starting pixel is already equals to the color, so in this case we don't have to do anything. We just have to return the entire image, right? So if our starting pixel is already equals to the color value, then we don't have to do anything, right? So this is one of the optimization that I'm adding over here, right? So if copy of starting row, right, and starting column is already equals to color, right, the new color, then we just have to return, right? We just have to return. We don't have to do anything. Okay. And I'm gonna make a row. Row is what len of copy. So here I'm just storing the number of rows, and the number of columns is going to be then I'm gonna make them rows. Rows going to be rows, and we have a cols, which is going to be column, number of column, which is going to be len of copy of 0, right? I hope you know this. Okay, q, as I'm telling again and again, this q is nothing but a dq, that is double-ended q, right? So that we're gonna perform the operation called pop left, and this can be happen only when we have a DQ. Okay. And initially, I'm just adding one element inside of a queue, and that element is nothing but the index of a starting element or a starting page, right? So we have a queue dot this dot append the starting row in the form of tuple, so that it become easy, right? The starting row or starting column. So I just adding this, and now here the main part. We're going to apply a loop. While until and unless the len of q is not going to empty or zero, we just have to perform the operation, right? Popping and then changing the color, right? So while len of q, okay, it's gonna be q, not equals to zero, right? So what we're going to do, we just have to pop one of the coordinate from our queue, and then also we need to store their coordinate, right? So at I comma j, I'm just storing their coordinate, which is going to be q dot pop left. So that is why I'm just using d, that I'm going to use a pop. Okay. Uh, at ij, you might wondering which type of values are we are just storing at ij. I just wanted to explain you what that is. Let's suppose in this queue, we do have the starting pixel, which is 1 comma 1, right? So 1 comma 1, right? Uh, let's rub this. I'm going to write bit shorter. Like here we have I, here we have J, and we are just popping the element from the queue, right? So popping the element from the queue, so it become 1 comma 1, right? We are just storing 1 comma 1 now inside our queue. So the value of I is going to be what? 1, right? And the value of J is going to be 1, right? So this is how it's going to work, right? So at I, we do have the row element, and at J, we do have a column element, right? Okay, I hope it is clear. Okay, so I comma j is equals to pop dot left. So we are just popping the element and just storing their value in I comma j respectively. Okay, so we do have a copy, then we don't have to change their color to new color, right? So copy of I comma I or jth element, that is just initially we have just pop out from our queue, so we need to change their color to color, so which is going to be color, which is our new color, right? And after doing this, so we have to traverse in 4 directions, right? Which is upward, downward, left side, or right side, right? So for that, again, we're going to apply a for loop in those 4 directions. So for x comma y, in x, I'm just storing the rowth element, or at y, I'm just storing the column element. So x comma y in, I'm just making a list. As I have told you over here, you can see uh, we just have to store these indices. We just have to store these indices inside our list, and then we'll need to iterate it. Right? I'm just storing as it is these indices inside our list. So that we're gonna move upward, downward, leftward, and rightward. Right? I hope it is clear. Okay, so inside this list in the form of tuple, I'm just storing it -1 comma 0 for what? Upward direction. Then we are just moving left side. So for that we have 0 comma -1, and then we are just moving downward direction. So for that we have 1 comma 0, right? And for uh, right side we have 0 comma 1. Okay, now I just forget this colon. Then we have to change our ith or jth indices to our updated indices, right? Which is going to be our new I is equals to what? X comma I, x plus I, right? what I'm doing is, look it over here. For example, look it in this problem. Okay, over here, if we have this element, right, and if we wanted to move upward direction, so what we can do is at ith means in column we are just adding one element, right? We are just adding one element. Okay, now look at over here at 0 comma 0th position. If we want to move upward direction, we are just adding. Okay, we are in upward direction, we just have to remove one, right? At upward direction, we are just removing one, right? And in this case, we have minus one. It means we are just adding minus one, right? We are just adding minus one. So we are adding a minus one, then only we just able to move upward, right? And at jth also we just adding a zero. So again we get a zero, right? So then only we are getting the index of the this the uppermost element, right? So this is what we are doing is we are just adding the element, and so that we're gonna get the new index, right? New values, right? So our new j, similarly for new j, we are just going to do is just y comma the previous value, right? The new value plus the previous. Okay. Now let's suppose if we move upward, so we do have some edge case, and I just wanted to discuss those edge cases. Uh, let's suppose let's encounter this element. If we want to move upward, we didn't have any element, right? We didn't have any element. And what is the value of rho? The value of rho is going to be what? Minus one. If I'm just going to indexing it, this will going to be 0, this will be 1. Here we have 2, here we have 0, here we have 1, or here we have. Now, let's suppose this is one of the element and we need to move upward direction. Upward direction means we are just going in the row, right? The next row, which is going to be minus 1th row, that doesn't exist. So if the value of I is going to be less than 0, so in that case we do have to skip that iteration, right? And another case, let's suppose this is the element, right? And if we wanted to move right side, we didn't have any element, right? So if the value of I is going to, sorry, here we have a column, right? If the value of column is going to equals to the length of calls, right? So in that case also we don't have to do anything. Similarly for rows, here if we didn't have any element at the downward direction, code, right? We didn't have any elements. So in this case, we do have to skip this iteration, right? Similarly, if we're gonna move the leftmost direction, which is going to be minus 1th column, so if the jth is going to be less than 0, means we don't have to reach to the minus 1th column. We don't have to skip that iteration, right? So these are the 4 edge cases, and I'm just going to write these edge cases as it is, right? If the new if the new I is going to be less than 0, or new I, this our newest ith index is going to be greater than equals to the row, right? The number of rows. Or let's talk about the column. Newest j is going to be less than 0, or if our going to be newest j is going to be greater than equals to false, right? I do have to write over here is rows. Okay. So in these situations, what we need to do is to just skip this iteration. So we're gonna use a continue, right? Okay, now one more edge case is like if our newest index is not equals to the starting pixel. Let's suppose this is our newest index and this index is not equals to our starting pixel, right? So we don't have to do anything. This is also one of the edge cases. So I'm just writing over here is like if copy of new I or new j is not equals to starting pixel, so we don't have to do anything, we just have to skip, right? So it's going to be starting pixel. So I'm just going to write over here is continue, just going to skip this iteration, right? So here we do have managed all the edge cases. And now let's add the element, our new element inside our queue. So let's add this queue dot append, which is going to be our new I, comma, new j, right? This is gonna be the index of our new element. And then also we have to change the color. So for that, I'm gonna write over here is copy of new I, comma, sorry, at the brackets, we're gonna write over here is new A. We have to change their color to the new color, which is going to be our already given in the question. And at the end, we do have to write our copy matrix, which is going to be return copy. And that's all. Let's run this code. Accepted. And let's submit this code. Alright. So here we have done this question. So if this explanation helps you to understand this graph related question, so make sure to like this video, subscribe to our channel, and I'm going to see you in the next video. Bye bye.